Hello. Hi guys, good morning. Welcome back to my video. Ki hal chal? I hope you're doing good. In this, we're gonna see maximum number of fish in a grid. It simply says that you're given a 2D array matrix and which is of size m cross n. As you can see, you are given a matrix of size m cross n. Now, basically, a land is nothing but a value of zero. A value of zero. All these are lands. All these are lands for you. Cool. And the other values, right? The other values is the value, like basically the other value, a water cell containing the grid r comma c fish, if it is more than zero. So if it is more than zero, it indicates there's a fish right here. There's a fish right here. Cool. Your ultimate aim is to do one thing. A fisher can start fishing at any water cell r comma c and can do the following operations: catch all the fish at r comma c, or move to an adjacent water cell. Okay, I have to return the maximum number of fish the fisher can catch if he chooses a starting cell optimally, or zero if no water cell exists. So obviously what the fisherman will do, let's try for all the possibilities. The first possibility is the fisherman will catch this specific fish, and then obviously he can move left, down, right, left, down, and up there's no space, left there's a land, down there's a land, only places move right. Okay, then I'll collect one more. Okay, this also collected. Can I move any further? No. And I have collected this. Okay, so for if the fisherman starts from here or starts from here, it will actually take all these fishes in this specific portion component, I can say as. So the fishes I can collect here is 3. Or what if I start from here, then go here, fishes collected will be 5. What if I start from here, go here? Okay, fishes collected will be 5. What if I start from here, go here? Fishes collected will be 7. So, what is the maximum of fishes I can collect? Obviously, 7. That is the reason my answer is 7. Now, just to showcase the same thing with a bigger example, how I can say is, again, imagine there are 1 fishes. Although I could have changed the number of fishes also in that, but imagine I have 1 fishes. So what I will do, I can start at any position. Let's say I start at here. Then I will go to its neighbor and try exploring all the neighbors as much as I can. As you can see, I'm exploring neighbors as much as I can. And then it's completed. Same way, I can maybe start from here, then explore the neighbors as much as I can, get the count of the values in that grid, and ultimately get the answer. And same way for this. So what it reminds you? Obviously, it reminds us for a component. What is happening? I'm starting the traversal in a graph. It's a grid. I can imagine this as I'm starting its traversal from any cell. I'm just exploring as much as I can, which means a simple DFS, just finding the corresponding component. Again, usually you find the corresponding component size, but here you just have to get the numbers and add them, so that will give you corresponding component size. Here the size means the addition of values in that specific component. And I can just get, okay, how much number of fishes are there. Same way, how many number of fishes are there, right? Same way, how many number of fishes are there. 1, 2, 3, 4, 5, 6. And again, this will help me. Whoever has the maximum number of fishes is my answer. Cool. So it's a simple getting the corresponding component size, where size is nothing but the addition of all the values in that specific component. How do you find component? We use either a BFS or a DFS traversal. Now, whenever you have to just find the component, iterate on all of the values, mark them as visited, I always recommend to use and try the DFS traversal rather than a BFS traversal. Why is that the case? Like I always recommend this is because DFS is pretty small. And you should do DFS also, but I will show you both the cases. How a DFS works. DFS works is, okay, I will put that. I'm, let's say, at this specific cell 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6, 7. I start at this cell, which is 3, 3, and then, okay, visit it, go to its neighbors. Neighbor is, one of them is 3, 2, other is 3, 4, and other is 2, 3. And then again visit them. When I say visit them, make sure to count it. Again, In a DFS, you go on to one neighbor, try to explore it fully, then come back, then go on to a different neighbor, right? This is how actual DFS works. If you don't know what is a DFS and how it works, I'll link the video in description. Please go and watch that. Now, coming on back, we know that this is a corresponding simple DFS which we can have. And yes, ultimately we can just start traversing it. Let's see the code. So firstly, I get the corresponding row and columns. And again, this is the maximum number of fish which I can get. In the very beginning, because I want to not visit the same cell twice, thus I take a visited array, right? Which will tell me, okay, which cell is actually visited or not. In the beginning, it is false. Then I go on to every cell, check if it is more than 0, which means it is a water cell, and if it is not visited, then go and run the DFS from that cell R comma C. Why and what this will do, let's say at the first time I land onto the first cell, this one, right? This is not visited, and also it is not 0, which means it is a water cell having someone which is a fish. So I will start visiting it, a simple DFS, visit, 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 visit. And also when I call the DFS will return the sum of values in this component. Now when this is visited, next time it goes on to next cell, this is already visited, so it is skipped, skipped, skipped. But you will see that when it will come here, it is not 0 and not visited, thus it will start visiting it, visit, 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 and get the sum of component. So DFS will give you the corresponding sum of component. Let's see the DFS. First, very base case, that if I go outside of the grid, make sure to return a 0, no sum of the component, or no addition in the sum of component. And if it is a 0, which means it's a land cell, or if it is already visited cell, please don't go on to it and simply return a 0. Make sure that this DFS is returning for that specific component what is the sum of fish values. Then firstly I make that fish as visited, or that cell as visited. Then in the fish count I will get the current cell, and I will try to explore my neighbors. I will go on to all of my neighbors in all the 4 directions as I mentioned here. Then I will call the DFS by all the directions. This is my new R, this is my new C, and keep on adding in my fish count, because I know fish count will return me the corresponding count of number of fishes, and ultimately get my answer. Because you are going on to all these cells exactly once, thus time is m into n, and you are also going on to all these cells, making that visited array and also doing that recursion. And recursion depth can also take O of m into n time, thus the space is also O of m into n. Cool. Again, the same thing can also be done by the BFS traversal. BFS simply says that get to the current cell, put that in the queue, explore its neighbors, right? Get this current cell, put that in the queue, explore its neighbors, put that current cell, get into the queue, explore its neighbors, put that current cell, get into the queue, explore its neighbors already visited. So this is how a queue works. Again, if you don't know how a queue works, or how a BFS works, do check out the video description. Exact same piece of code that if something is not visited, just go and call the BFS function. BFS here will tell me, for starting at this R comma C, for that specific component, what is the size, when I say size, count of number of fish values in that component. The BFS uses a queue, so I have a queue. Again, I can take a cell also as a class, but pair also works. So I will push the first cell and also mark that as visited. Until my queue is empty, I'll go and explore all of its, all of the, firstly get the current node, then go and explore all of its neighbors. And again, as we did previously also, increase the corresponding fish count by adding the current cell. Here, the fish count is initialized to 0. And then I'll get the new row, new column, check if it is inside the bounds of the array, and also it is a water value, like water cell, and also it is not visited. In that case, push that in the queue and also mark that as visited. Cool. And ultimately get the corresponding fish count. Cool. Again, the same time of O of, O of m into n, because you are visiting every cell exactly once, and same space because you are using q and the visited array here as well. I hope you guys got it. Again, it's a straightforward, pretty simple problem. It's just that rather than finding the size of the granted component, it is finding the component size, which ultimately means the count of number of water cells or fish cells in the component. Bye bye, take care.